All right, here's the way the elements looked at the time of the American Revolution. The alchemists gave us arsenic, antimony, and bismuth in the 12th, 13th, 14th centuries. In 13th century India, there was zinc, isolated. There's a tall zinc pillar still standing there. Platinum is an American metal, was unknown to the Europeans. It was discovered when the Spanish came to the Americas. Actually, it's kind of ironic because plata is silver, so platina is sort of like a diminutive of silver, which in point of fact is backwards because silver melts at 962 degrees Celsius, platinum melts at 1768. It is nobler than silver. It has catalytic properties. It is even fashionable in jewelry now, if you know how to work with it, because gold melts at 1063 and platinum melts at 1762. A lot of jewelers can't work with platinum. It's too high melting. It's a fantastic metal. It's an American metal. It really is. I mean, it's an American metal. I didn't make this up. It's true. And then we see these other elements. Discovered. Now we see modern science. So what does it mean? Discovered 1766. There was no hydrogen before 1766. They found it? No, it means that Cavendish isolated it and documented its properties. Hence it was discovered. Right? Now, I've been cheating here. This is actually lined up in a way that we already know where the story is going to end with this, with the periodic table. I'm just lying them on the table in a way that makes it possible to anticipate. But this was the first table of elements that is of record, and this was by John Dalton, the English chemist, who put these in order of atomic mass. They're organized in ascending order of atomic mass, and he also started a system of chemical symbols. And you can see that iron has I with a circle around it, and zinc has Z with a circle around it. And the Swedish chemist Berzelius said, I don't think the French are going to like to use I with a circle around it for iron, or Germans aren't going to like that. We better choose something a little bit neutral. So they chose Latin, and that's why iron is Fe for ferrum and gold is Au for autumn and so on. But this was the first attempt. John Dalton actually was a polymath. He was also working on vision, human vision, and he suffered from an affliction that is present in about 10% of men, which is red-green color blindness, and he did the original work on red-green color blindness. In fact, in some circles it is known as Daltonism. It's the same man, John Dalton. Other classifications, Dobereiner in Jena talked about triads. If you took the atomic mass of chlorine, added it to the atomic mass of iodine, divided by 2, you get something that's not too far off the atomic mass of bromine. Newlands was a musician, and he talked about octaves. So if you start here, if this is a diatonic scale, so this is C, D, E, F, G, A, B, C. So potassium lies an octave away from sodium. He was ridiculed. They said, have you considered perhaps putting the elements in alphabetical order? They were cruel. Scientists can be very cruel to new ideas. And in fact, in your book, this is some of Newland's work, and you can see to what extent it helps understand things. But the first proper organization came in 1869 with Mendeleev, and also 1870 with Luther Meyer in Tübingen. The periodic table as we know it. And this is the set of elements that were known at the time. And this is a page from the paper in which Mendeleev published the periodic table. And here's the smoking gun right here. It's right here where he says, in this new system, in this proposed system, there are very many missing elements. Very many missing elements. That was the key. Because he knew that even though arsenic has the atomic mass next highest to that of zinc, not to put arsenic under aluminum, not to put it under silicon, it had more in common with phosphorus. So he put it under phosphorus. And so did Meyer. But what Mendeleev did, which was a first, he said, there are missing elements here. There is an element that lies between silicon and tin, and I predict what its mass will be. I predict what its chemical formulation will be, how it will react with oxygen. The predictions. And how did he get this? Because he used to travel by train, and he would sit in the train station on his trunk playing solitaire. And he'd be going down one suit, and then there'd be a gap. He'd go down the other suit and he could go farther. And so the concept of, I know there should be an 8 of spades here, but I have to stop at the 9. I've got a 7, but there's something in there. Triggered his imagination and led him to have the courage to say, there are elements there, and I will predict their properties. And when they were discovered, how close he was is shocking, absolutely shocking. So we'll get to that next day, but before you go, I want to leave you with this. This is the portrait of Mendeleev that you typically see, this man on in years, disheveled, sort of mad scientist look. Don't remember that. Look at this. This is Mendeleev, age 35, when he proposed the periodic table of the elements. Okay, we'll adjourn. We'll see you on Friday.